All right. Good evening. My name is Frederick Brain, and this is going to be the code review for the Category 2 artifact that will be under the algorithm and data structure. Unfortunately, this is not the project I was hoping to do, and I am still working on attaining my finished project zip file for the CS350 Systems Architecture and Design class that I originally discussed in the paper, where I will use the microcontroller to set the min max heat for like a smart thermostat. Given the situation with my computer and it having to be factory reset, I'm going to use this project as a backup in case I am unable to retrieve the other. The main purpose of this course was to study the newest technological advances and adaptation in the computer science field. This class focused heavily around machine and AI learning and deep Q learning and understanding the processes behind it. So, the theme of this project is to produce a popular treasure hunt game in which the player needs to find the treasure before the pirate does. We did not write the entire code for this course, but we were responsible for writing the part of the game that represents the intelligent agent, or in other words, the pirate. Now, the project provided two Python classes and a .ipynb notebook. The first class you'll see here is the treasure maze.py, which represents the environment, including a maze object defined as a matrix. The second class is going to be the game experience.py, which stores the episodes, which are otherwise known as the states that come between the initial state and the terminal state. And then last, we have the treasure hunt game .ipynb notebook, which shows how to play the game. Now, what does the code do? What are the features, functions of the existing code that we already have here? If you look, the features include the creation of a maze by using a 8 by 8 matrix as the maze object. So the helper function will allow a visual representation of the maze object, and then the pirate is going to be able to move in four directions: up, down, left, and right. And then what our job will be is to design the machine learning or the deep Q learning, and essentially run a test to see how accurate and how quick the the agent or the pirate is able to find the treasure, and if it is able to complete the game. Now, when looking at this code, as far as the treasuremaze.py and the gameexperience.py, as if when we're looking at this, we're looking at first the structure. We are going to look at documentation, the variables, and then I would say the loops and branches, just because for the most part, aside from some integers, there's not really any, and some floating numbers, there's not really any arithmetic operations that we have going on our end. That is done throughout the actual testing phase. So, like I said, we're going to be focusing on structure, documentation, variables, and the loops and the branches. So, structure wise, I mean, as far as the code being efficient, yes, I believe the code is efficient, and I would say that it implements the design, which you can see here if we scroll down to the bottom. The pirate does actually find its way to the end of the game and completes its actual testing phase. And it looks like it did it 137 times in a max of 14.25 minutes with a total of 22 episodes. So not bad at all. Now, as far as the actual the code goes here, when you're looking at if it's efficient, if it meets coding standards, yes, it does. There are lots of comments in here. It's not too commented, but it explains exactly what's going on without having to be overloaded with clutter within the actual code. You can see the indentation, the brackets, the white space is all unison or organized. It's a very readable code, as you can see throughout here. Again, indentation. If we look at your loops and branches, they construct complete, correct code. They essentially go ahead and take the statements that are enclosed within the if statements, they run them, and then they end the actual statement by either validating or invalidating the action that is supposed to happen or is not supposed to happen. So there's nothing as far as repeated loops, repeated blocks, um, incorrect initializations or variables, uh, if else statements that are going to affect the overall correctness of the test and what it is we are trying to perform within this code. So just continuing on down, as you can see again, the indentation, it's just very neat code. It looks very good. Your variables, they are not redundant. They are assigned names that are particular to their own. And then if we move over to your game experience.py, you're going to see the same thing over here. You're going to see that it's very simple. It's to the point. You're going to get your comments so that any developers coming in after this is initially developed know what it is that's going on, and they know where to pick up if the person who developed it is no longer around. And when we go down, again, you can see it's just very organized. It's very readable. The documentation, as far as all of these go, the code is clearly and adequately documented. It's easy to maintain due to the comments and the style. And I mean, the comments are all consistent with the code. Again, the variables, they're properly defined. They have meaningful, consistent, clear names. And they all have the proper consistency or casting, and there are no redundant or unused variables within this code. So again, we'll look lastly at the actual Jupyter notebook here, because again, I mentioned earlier how we made a 8x8 block matrix, and that is what was going to be used for the actual maze itself. And as you can see here, it's very well done as far as the organization. I do realize now that probably could have put some comments in here. I don't think I actually provided any comments on the Jupyter portion of this, but certainly something that I could go back and do. Um, Here, again, very organized. Everything is assigned properly, works properly, and it is basically a helper function that allows the actual representation of the maze object, right? So essentially, we're using a for loop here, and as you can see, we assign it the rows, the columns, and then we're basically outputting the pirate cells and the treasure cells. Moving on, if we come down a little bit, you can see it looks like we did get into a few comments here, making it nice and easy as far as setting up the directional standpoint of the pirate agent, where they can go, and then actually getting into seeing the visual standpoint, and then creating a function that is going to have the pirate play the game, and then your completion check, and the actual portion that we, the students, completed as far as the Q training algorithm. So when we go into this code, again, you can see how organized it is, the indentation, the white space, the variables not being redundant. They are assigned properly. They are clear. They're concise. The commenting is clear. It's concise. The loops, branches, they do exactly what they are meant to do. There's no repeated blocks, no improper loops. And then as we go on, that's when you get into the test of the model and the results down at the bottom. So as far as debugging goes, the code does not need debugged. It is uh, properly written code. The code is good as far as any type of debugging goes. Sure, I could get into a different software and go a little deeper into the debugging, but as far as this goes, it's well written code. As far as the enhancement for this particular project, I'm not really sure because I didn't have a lot of time to think of one as I was trying to figure out how to get my other project back. But I think if I were to do it, I am going to look into probably just seeing how I can improve the accuracy and then the actual time that it takes to complete this. So as we see here, it took 137 tries, and then it took a total of 14.25 minutes. So what I would like to do is I would really just like to improve won 137 times. So I would like it to win. I would like it to be more accurate, and then I would actually like it to work faster, if possible. So that is what I am going to try to do as far as the artifact goes. Um, when it comes to the course outcome, off the top of my head, the outcome I would probably align with this one the most is going to be the enhancement, based around the ability to demonstrate the use of innovative techniques, skills, and tools for the purpose of implementing computer solutions that deliver the highest value, quality assurance, and industry specific goals. Reason being is we're advancing in technology every day, and AI, artificial intelligence, is something we are certainly very new to. Machine learning, we are a little more familiar with, but it's just a whole new area of experimentation. And we really have to be mindful about what we're doing and the safety to the users and the public. And I think being able to use the techniques, skills, and tools, resources that we have developed as computer science, and understanding those processes will really help deliver value to products or whatever technology it be in the future that we put out in the industry, development wise, whether it be robots in 5 years that are completely capable of helping you around the house, or something like what we already have, which is just improvement of autonomous vehicles. Thank you. That was my category 2 code review for algorithms and data structures, and I thank you for watching.